All right. Can everyone hear me? How's everyone doing tonight? Good. Beautiful weather we're having, eh? All right. And a beautiful time to prepare for some Math 1 MP3. So I hope everyone's doing well tonight. Now, I apologize. I know there was a bit of confusion with setting up the times for review sessions. We've discovered a bunch of time conflicts with stuff this week. So we're actually going to be running 2 review sessions. One is today, obviously at this time, and one is going to be tomorrow at 6 o'clock. You're welcome to attend the one tomorrow if you'd like. You don't have to. I think we're just going to be covering the same material as tonight, but if you feel that you could use a bit of extra practice, you're more than welcome to come for that one as well. So with that out of the way, I'd like to go over questions from both of the tests as well as any select questions from the practice problem set. Do you have any questions you'd like to see covered that we can add on before we get to those? And if not, if you'd like to suggest one as we're going through the review session, feel free to do that as well. All right, do you have a preference for which test you'd like to start off with? 2? Test 2? All right, we can start off with test 2. All right, so has everyone, can we just do a show of hands? How many people have had a chance to look at the review session or look at the test before the review session? Okay, good number of people. In that case, we'll take it a little bit slower just to make sure we're getting everything. So let's get started. All right, so the first question is the Fibonacci sequence, and it tells us that the Fibonacci sequence is defined recursively. So it gives us the first term and the second term, and does everyone know what it means for something to be defined recursively? So it's giving us the fact that we're getting a general term, and it's showing that that general term is based off of the couple terms before it. And it's asking us to create the variable f list, which is going to store the first 50 Fibonacci numbers. It's going to be a list of the first Fibonacci numbers. Have any ideas on how we could solve this one? Give you a second to think that one over. All right, so why don't we try this? Let's first start by initializing a list. F list. And we want this to obviously be a list to store our integer components. And since we're given that f1 is equal to 1 and f2 is equal to 1, why don't we just put that the first 2 elements in that list are going to be 1 and 1. Okay, so now we're also given that the length of the list is going to be 50 because we want to contain the first 50 Fibonacci numbers. So what we can do is why don't we set up some loop that tells us to keep going until we've got the first 50 Fibonacci numbers, right? So what kind of loop do we want to use here? For loop, while loop? For loop, we've got while loop here, we've got for loop over here. You can actually do it with either. Keep in mind that all for loops are actually just while loops that are kind of hidden behind some syntax there. But since I heard while loop first, why don't we try with the while loop, and we can also try with a for loop if you like. So we want to make sure that the length of the list is going to be equal to 50. So why don't we say while the length of f list is less than 50. See, the thing is, when it is less than 50, we have a problem. So when it is less than 50, we want to do something to it. We want to add another element in the list. And then once it hits 50, we're good. So we break out of the while loop. Okay, so while it's less than 50, we want to do something to it. Now, what's that something we want to do? What do we want to do here? We want to append. Yeah, I'll go for it in the back.
So we want to append a new integer to the list that's equal to the term before it and the term before that.
Beautiful. That's a perfect answer. Yes. So we want to append a term which is equal to the sum of the term before it and the term before that. So if this makes sense to everyone, why don't we do this? So we'd like to append an item to the list. So we're going to flist.append. And we're going to want to add the sum of the previous element and the element that is 2 before. So now the thing is, I want to add, so let's say we're generating a list right here. Let's say I want to, so I'm going to write these comments in purple or in blue here. let's say we want to add another term to the end of this. And I want it to be based off of these previous two terms. So I want to add some term here that's based off of the previous two terms. So I want to try and find a way to access the previous two elements. But you know what? I just don't know how. Can anyone help me with this? So if I want to get access to the previous two elements, is there a way? Oh, oops. I've already written it here. I want to access the previous two elements in this list. So how am I going to go about doing that? Exactly. We can index at -2, and we're also going to want to index at -1. And notice I'm adding them together before appending it because we want to append the sum of those two. And turns out we're actually done. So all we have to do is maybe if we want to print flist, but that may or may not be necessary. All right, so does that make sense to everyone? What we just done? Also, let me know if I'm going too slow or too fast. I'm not sure about the level of where we're all feeling comfortable with in this class. So just let me know. All right. So question 2 says, assume that we've completed part A and we have the list, F-list of Fibonacci numbers. So we've got a list that's 50 long and it contains the first 50 Fibonacci numbers. And then it now says we have to create a new list, this new list called n digits, which is defined where each n digit at I is the number of digits in f at I. So I'll stop there for a second. Does that make sense to everyone? So we're going to want to generate a new list based off of how long or how many digits are in each number of the previous list. So if we read out the first 50 terms of the Fibonacci sequence, 1, 1, 2, 3, 5, 8. Actually, I'll keep going to a couple of two-digit numbers here. So notice, since this first one has 1 digit, it's going to be 1. The next element has 1 digit. Next element, these all have 1 digit. Here, 13 has 2 digits. So we're basically just grabbing the length of each number. So let's try and figure out how to do that. So the first thing is, why don't we start by doing the same thing we did in the previous example. Okay, let me just keep the same color scheme here. So we're going to initialize a list that is going to store each of the lengths. So we're going to initialize this list here. And now we want to try and grab the lengths of each element in the previous list. So we want to grab how many digits each element in the Fibonacci list will have. So how might we do that? So I want to grab each of these elements. Why don't we try by iterating through our first list? So let's say this, for I in F list, where each I is going to be the element. Here we're going to have 1, we're going to have 1, 2. And why don't we do this? We want to append something to n digits. And I want to try and append the length. I want to try and append the length of each element I. So what if I try doing this? n digits dot append the length of I. So I'll give you a sec to think about that one. What do we think? Does that look correct? We're appending the length of I to n digits. We're looping through F list to grab each I before appending the length. I heard something here. Hold on to that idea. What's wrong with this code right here? All right, well, let's take a look at what it's actually doing. So let's loop through it the first time. So we're saying for I in F list, the first thing we're going to do is grab this 1. And now we're going to try and append the length of 1. So in order to do that, first, Python's going to calculate the length of 1. So are we seeing any errors with this? But this is happening during this step right here. Are there any errors? Oh, hey, stand hand in the back.
Yeah, so basically you're trying to calculate the length of an integer, which Python can't really do.
Exactly. So in case everyone didn't hear that, we're trying to calculate the length of an integer. And are we allowed to calculate the length of an integer? No, we can't. So what clever technique could we use to get around this? I heard string earlier from Nathany. We're going to try and convert this integer into a string first, and then we can take the length. So all I'm going to do here is I'm going to use some magic here. Unfortunately, you won't be able to do this on the test, but let's, we're just going to take the string of the length of I. And then everything else is going to stay the same. Does that make sense to everyone? Any questions? We all happy with that one? All right. Let's look at question 2. Okay, so question 2 asks, it says, look at the following code. It's going to import numpy as np, and it's defining 2 functions. So we're going to define f and define fp at x. And both of them are going to return, I guess, a different polynomial function here. It's going to give us some tolerance value, and we're doing some arithmetic. And we're asking, what will Python print in line 12 when it's the first time through the loop? So, let's see. I'll give you a couple seconds to think about that one. Well, how are we going to try and traverse this code here? Maybe let's start from the beginning. So this function block, that's going to be executed a little bit later. So it's not going to be executed right away. So let's jump down here to line 8. So we're setting some tolerance value. And we're also setting some x value here, x is equal to 1. And what it's saying is while np dot absolute value, so basically while numpy, the absolute value, this command right here is just imported from numpy. So while the absolute value of f at x is greater or equal to our tolerance, we're going to change our x value. We're going to set it to x minus f of x over f prime. Now this method might look very familiar if you've done it in one of your calc classes. But let's just try and work through. So here, I'm actually going to write down what f of x is doing. And I'm going to write down what f prime of x is doing. Okay, awesome. So now, let's try and do the first thing that we see here. We want f at x. And we know x is 1. So let's try and calculate f at 1. So f at 1 is going to be 2 times 1 squared minus 9 times 1 plus 4. That's going to give us negative 3. Okay, and let's calculate f prime at 1, which is going to be 4 times 1 minus 9, which is going to be negative 5. Okay, so now we see that the absolute value of f of x, we take the absolute value of f of 1, and we see that that's greater or equal to our tolerance, because the absolute value of negative 3, which is 3, is greater or equal to 0.001. So since this is greater or equal to it, we want to execute what's inside the code, inside this while block. So we're going to go, x is going to turn into our current value, which is 1 minus, and then we need f of 1, which is 3, over f prime at 1, which is negative 5. Okay, so now this is going to turn into, we're going to get 1, this is negative 3. We're going to get 1 minus 0.6, which is equal to 0.4. And because line 12 here is just printing it right away, this is what it's going to print out. Does that make sense with everyone? Everyone happy with that one? Awesome. Okay. And then part B, it asks, what does the output in line 14 represent in the context of the task the code is trying to accomplish? So I'll give you a sec to think about that one as well. So what does line 14 do? Notice how line 14 is outside of our while block here. So we have this while block that says while we're greater or equal to the tolerance, we're going to make something get smaller and smaller. Or maybe not necessarily smaller or smaller, but notice how we started with our f at 1 here, and we're now at 0.4. So we're getting closer and closer to something. So So again, if you're familiar with this method, this is called Newton's method. Does everyone remember what Newton's method does? So Newton's method, our goal is to try and find an approximation for the solutions, or the x-intercepts of our original function, f prime at x. Okay, and so what's going to happen is our x value that we're getting is slowly going to approach the solution. So the more and more we do this while loop, it's going to approach the actual zero of the function. However, we've set it as a while loop so that it's going to keep approaching until it's some closeness away. So what's going to happen is once it's within that closeness of away, it's actually going to stop. So when it stops, this is actually printing, so line 14 here, it's printing the first approximation that's within our tolerance. So it's really printing an x-intercept. It's printing an x-intercept, or rather, the first approximation within our tolerance. Does that make sense to everyone? Everyone happy with that one? All right. How about we move on to question 3? All right, so in question 3, we're given that we represent a polynomial of degree n as a list of its coefficients. And it gives us an example of a polynomial there. Okay, and it tells us we have to write a function called multiply polynomial, which multiplies a given polynomial p by 1 plus x, and then returns the product as a list of coefficients. A couple seconds to think about that one. Do we have any thoughts on what this one's going to do? Well, you know what? Why don't we try? Let's try multiplying a polynomial by 1 plus x. And I know it gives us a representation of a polynomial here. Why don't we try and use this polynomial here? So we have 6 minus 5x plus x cubed. And let's multiply it by 1 plus x. All right, so what are we going to get here? Let's do this distributivity here, property here. So we're going to do 1 times 6, 1 times negative 5x, and a 1 times x cubed. I'm going to put this in one color here. And we're also going to get 6x minus 5x squared plus x to the 4. So why don't I choose to keep this separate here? So maybe what we can do is we can try and generate 2 lists that are represented by each of them, and then try and find a way to add those lists together. So notice here, this list, or these numbers, are just the same as x times 6 minus 5x plus x cubed. Now also remember that if we're multiplying something by x, really all we're doing is we're just shifting its position in the list, because our constant now becomes our x term becomes our x squared term, our x squared term becomes our x cubed term, so on and so forth. So why don't we do this? We're going to create 2 lists. I'm going to call one C list. So C list is going to be our current list, right? It's the list that we already started with. And that's going to represent the list that's just multiplied by 1. So C list is going to be equal to our original, do we have our original? Our original list is P. C list is going to be P. And we're going to try and take the entire slice at P. Now, I'm going to ask you, why can't I just write C list equals P? So this is actually just a little hidden quirk in Python. I'm not sure if we've gone over it yet. But if you set a list equal to another list, it's actually just going to, they're both going to be pointers to the same object. So if you modify one, it's going to change the other. So just the good way is whenever you're trying to copy a list, just slice it from the beginning all the way to the end. Okay, so we've got C list is going to be our copy of P, and we're also going to need a new list. So we're going to call it, how about we call it X list? So it's just going to be the list that we already have, And why don't we make it like this? We want to add, let's add a 0 element, because if we take this green thing right here, we multiply it by x, so we end up getting this red portion here. Notice there's no more 0 term, or there's no more constant term. So if 0 represents our constant term, why don't we take the 0 list and we're going to add on our list p. So we're just going to append p to the end of 0. You could also write 0 dot, so this list here, dot extend p. That also works. But either way, now we're going to have this blue list, C, which is called C list, which represents this portion right here. And we're going to have this red list, which represents x times our list. And now what we should do is, well, why don't we try adding each coefficient to each other? And that's going to complete our multiplication. So let's iterate through. Now, we're going to have C list and X list, and these lists are going to be of different lengths. So which one's going to be longer? One one's going to be longer. We extended one of them. Our X list is going to have one more element in it. So why don't we iterate through C list? So for I in C list, actually, why don't we try and iterate through the positions in C list? So we're going to do for I in range, len, C list. And that way we can do it by index. Because then now, each I in C list will also correspond to some index in X list, which is our new list. Okay, so while we're iterating through C list, let's add the element at our position I in C list to our X list. So we're going to say X list indexed at I plus equals our C list at I. So now our X list is going to turn into the new list that we're trying to return. Okay, and now that we've built up this new list, which is, I guess, completely full of all the new coefficients, we can just return X list. Does this make sense? Everyone happy with this one? I know this one's a little bit more complicated. Do you want me to go over any parts of this one that might have been a bit more confusing? Everyone happy with that one? All right. Let's move on to part 4. So question 4 says, Taylor's writing a function called echo. Okay, and echo is supposed to echo the characters in a string an increasing number of times in the following ways. The first character is not repeated, the second character is repeated once, the third character is repeated twice, so on and so forth. And the output of, if S is cloud, then the output should be as follows. So, Taylor wrote some code. What does Taylor's code output? All right, well, let's try and look through. So for I in range, the len of S. What is the len of S? What is the len of cloud right here? It's 5 letters long. So 5 times, we're going to take a look. We're going to index S at I. So let's start for 0. Let's say I is 0. And we already know that S is cloud, because we're passing cloud as an argument to our function S. Okay, so S is already cloud. Now we're going to add S at 0 times 0. Well, anything times 0 is nothing. So nothing's going to happen. We're going to iterate through again. Now I is going to be 1. So we're going to add S at 1 times 1. So we're going to add 1 copy of S at 1. Now, if our input is cloud, what's S at 1? It's L. So we're going to add L here. Okay, let's go again. When I is 2, we're going to add S at 2 times. So S at 2 here, O, so we're going to add O twice. No, notice this is already not looking like the output that we wanted. We wanted cloud like this. But let's keep going. Let's try one more time. So we're gonna, let's say I is 3. We're gonna add 3 times. We're gonna add s at 3. So s at 3 is u. So we're gonna add u 3 times. 1, 2, 3. And the same thing is gonna happen. I'm gonna skip ahead, but with the final character d. And this is our final output. So notice something must have happened in the code, you know? Taylor tried, Taylor couldn't get it, but that's okay. Because it looks like we're gonna try and fix Taylor's code. So part B, we're gonna write a new function, or new code for the function echo of s, so that it produces the desired output. How are we gonna do that? All right, well, the first thing that you'll note is that in Taylor's version, where we had s here, we're just adding stuff to the string s that already existed. So maybe, why don't we try initializing a new string, and we're going to try and change that one. So let's start by saying string. It's going to be an empty string. Okay, and now what we're going to want to do is we're going to want to loop through a certain amount of times here. Now let's notice our first letter in cloud is going to be repeated once. Then our second letter is going to be repeated twice. And our third letter is going to be repeated 3 times. And so on and so forth. Something to notice here is that this 1, 2, 3, the position, doesn't line up with the index if it was a string. So remember, the index here would start from 0. So 0, 1, 2. Okay, so why don't we do this? Let's loop through the length of cloud. So for I in range, we're going to grab the len of s. Remember we talked about earlier, we're going to try and loop through the length so that we're able to index at each point. And what we're going to want to do is we're going to want to try and add stuff to string. We're going to want to concatenate to the end of string here. All right, so let's say I was going to do this. Let's take exactly what Taylor did here. S at I times I. How is this looking? Let's see. What's going to happen here? Let's say we're starting with the word cloud again. Let's start with I as 0. So we're going to take S at 0, which is going to be C. So we're going to have 0 copies of C. Is that right? That's not right, because we want 1 copy of C. So actually, we actually want 1 more copy than the index. So just easy way to solve this one. We're just going to add 1 to our multiplication here. Remember, we're going to want to add brackets. What happens if I forgot to do that here? What's going to happen? That is an issue. Actually, I like the answer that we're going to add 1 to the string, because what's going to happen is this is a string, and this is a string. But when we try and add this, we're going to be adding an integer. Are we allowed to add integers to strings? No. The point is, make sure we remember our brackets. And then we can just return our string. Remember, anytime we have a function, we're going to want to remember the return statement. We're done. Is everyone happy with that one? Any questions? All right. Let's go to question 5. All right, so 5 says, in Python, an n by n matrix can be represented as a list of n elements, where each element is a list representing 1 row of the matrix. So it says to illustrate, it gives us an example m, and it asks precisely what Python will print in line 5. And what does this answer represent? I'll give you a minute to think about this one right here. A mystery function. Everyone like list comprehensions? Okay, so let's take a look at n. So it's going to say for k in range of 0 to n. So this block is really saying, okay, we want something n times. So n times. Okay, and we want to do 0 times n. So we want n copies of this 0 list and we want it n times. Okay, so let's actually look at what it's going to be doing here. So we're going to have this one list. And inside it, we're going to have another list. And that's going to be filled with n copies of 0. Okay, so n is 4, so we're going to have n copies of 0. Now we've got one of those lists complete. But we wanted this list inside the list to be printed 4 times. So let's repeat that another 3 times here. So 0, 0, 0, 0. Just remember 4 zeros in each list. And we want 4 lists. Okay. So now we've got a matrix that looks like it's filled entirely with zeros. 4 by 4 and a 0. So what do we call this matrix? We can just shout it out. This is the 0 matrix. The 0 matrix. Awesome. So that's going to print out now. It's going to look like this. So it won't actually print this, but this is essentially what it represents. So we've all seen this in 1B if you've taken it. And I can actually use this for the next question here, so I can move this down. Okay, so using our function from A, we're going to write code that's going to create the n by n identity matrix. So remember, the identity matrix is we're going to replace all of these zeros along the diagonal with 1s. So let's try and figure out how we're going to do that. Okay, now let's actually take a look. I'm going to write down the index of each of these here. So in each row, we're going to have a 0, 1, 2, 3. And we're also going to have a 0, 1, and 2, 3 column. Now notice something special about the identity matrix is when we end up replacing these zeros with 1s, do each of these zeros share some common indices here? Notice this top 0 is at the position 0, 0. This next one is at position 1, 1, at 2, 2, and at 3, 3. So what we can do is we can actually use a single for loop here. So what we're going to do is we're going to, well actually, why don't we do this? Let's build up the previous matrix using our mystery function. So now matrix is going to be defined by the identity matrix. And now, since it's n by n, let's loop through n times. So for I in range n, and let's replace every matrix entry at 0, 0, at 1, 1, at 2, 2. So at I, with 1. Does that make sense? So what we're going to be essentially doing here is replacing our 0, 0, our 1, 1, our ith entry with the number 1. Does that make sense for everyone? Yeah. Any questions for that one? All right. So why don't we move on to the third test here? How does that sound? All right. Third test here, first question. We can move a little bit faster with the multiple choice if you'd like. I don't know, how's the pace so far? Good, all right. So first question says, okay, what's the output of the given code? All right, so all we're gonna wanna do is we're gonna print s at 3. Notice we've got a dictionary here. So what is that point in here, that 3? What is that referring to? Go for it. The key, exactly. Okay, so let's take s at the key. So let's look through the keys. I see a key of 3 here. And what's the value associated with that key? 8, perfect. So 1 is D. Okay, question 2 says, we want to print s at 3 again. Now notice, is s still a dictionary here? No, s is not a dictionary here. What's s? S is a set. So do we have an s at 3 here? No. So here we have an error. S at 3 is not defined. Okay.
Wait, Kyle, what was that? What were you saying?
Because we don't have a key here, because this isn't a dictionary. This is a set. Here we have question 3 here. It's going to define, we have this function h. We're going to try and look through. Actually, I want you to take a look at this one, because this is a question that I messed up on one of the tests. And this one's really got me. This one's a little bit hard to see the trick here, so I'm going to give you a minute to think about that one. And then we're all going to vote. How about that sound? How does that sound? Let's vote on each of the possible answers here. I'll give you a second to think about that one. All right, everyone ready? So here's how we're gonna do the vote, okay? For the 42 there. We're either gonna vote for 42 or for not 42. Okay, so put your hand up if you think 42 is the answer. Okay, put your hand up if you think not 42. Not 42. James, do you put your hand up for 42? Yeah. Okay. So James, why do you think it's 42?
So we're, when we're printing H2 of 3, we're setting x equals to 2 and max steps to 3.
Yeah, you're right.
So I'm pretty sure for the first go around for some, you would have like 2 to the power of 1.
Okay.
Plus, then would be 2 to the power of 3, so it would be 2 plus 8.
Okay, so you're saying 2 plus 8
5, so 32.
plus 32. Okay, and what's that? What's that sum right here?
42.
That's 42. All right, who from the other side thinks it's not 42? Anyone who wants to give a shot at it? Lucas? No? All right. Oh, go for it. Yes.
Return is within the loop still?
Yes. Oh my gosh. Okay. So let's take a look at this one. Notice the return statement isn't where you would expect it. Normally you'd expect it to start here. But notice we've actually started this return inside, it's indented. This return's inside the for loop. So actually, we're not going to even get to the 8 plus 32 part. It's just going to get to 2, and it's going to return. So this is really tricky. Always watch your indents here. So actually, 2 is the right answer for this one. It's very tricky. Is everyone happy with that one, or want to have any questions about this one before we move on? All right, awesome. Don't worry if you get tricked by stuff like this. Believe me, it happens a lot. So a lot of coding is trying to make sure you catch those tricks. All right, so question 4. We're going to want to print out the output of this one here. Okay, so we're going to get A is the set of Monday, B is the set of Wednesday, and C is just an empty set. Okay, well, why don't we try and figure out what A and B actually are? Okay, so if I wrote that A is going to be equal to this set here. Oh, sorry. A is going to be a set containing a single element Monday. Is that correct? Everyone happy with that one? Do another row. Is that right? And hands high. Is that right? I see no hands. That means it's wrong, right? Who says it's wrong? I still see no hands. Have you done this in class, where we try and take a set of a string? Like that. It's an interesting little quirk. Python is filled with quirks. This actually won't give you this. When you take a set of a string, it's actually going to give you this. It's going to give you a set containing each letter as an individual string. Oh. And then, N, so on and so forth. Actually, I'll write up the entire set. Like this. So let me ask, here's a survey. Who would have guessed that it does this? Saffron, you would have guessed it? No way. We got a smart cookie in here. All right. So, and then the same thing's going to happen with our set Wednesday. I'm not going to write out the entire thing, but you get the picture here. So what's going to happen is we're going to be looping through the elements in A. So we're going to be looping through M, O, N, D, A, and Y. And if that element is not in our set B, we're going to add the element to our set S. We're going to add it to our empty set. So, is the letter M in Wednesday? No. So let's add it to S. Okay, what about the letter O? Is O in Wednesday? No. So we're going to add O. Okay, what about N? N in Wednesday? Yes. And of course, every letter in day is going to be in Wednesday. So D, A, and Y are on Wednesday. So I guess this looks like it, huh? Okay, so let's check. Is this one of the multiple choice answers? Sure is. So it looks like we found our answer to this one. Anyone have any questions about this one? No? So it's just a little bit of a quirk where taking the set of a string is going to separate it into individual letters. All right, so let's take a look at question 5. This is another guess the output of the code. And here we've got a dictionary, D. So we're going to have milk, fruit, chocolate, bread. This should be named all the stuff that I want to eat right now. And okay, so what we're going to do is we're going to define this function where it's going to take 3 things, M, S, and T, and it's going to return M times the dictionary at T divided by the dictionary at S. So how are we going to do this one? Well, first we know M is 12. It's given in our function. We know S is milk. And we know T is bread. Okay, so what's D at milk? I know that sounds a little bit weird. No need to think D at some index. But what's D at milk? It's going to be 60. Okay. And what's D at bread going to be? 54. So we're going to take D at our milk. It's going to be 60. And we're going to have D at our bread. It's going to be 54. So now all we're going to do is we're going to get that. Remember, this is D of T, so we're going to do M times, so 12 times D at T, which is bread, so 12 times 54, divided by D at milk, which is 12. Oh, sorry, which is 60. And 12 times 54 over 60, I don't have a calculator on me, but that is 10.8. 10.8. Everyone happy with that one? Any questions about that one? I'm getting some puzzled faces. They were a little bit sneaky here again. Yeah. So remember, notice they flipped the order. They have T and S at the top, but if we look all the way back to where the function was defined, our function goes S and then T. So make sure you watch out for that one as well, guys. All right. Question 6. All right, so 6, we're defining another dictionary. Got 1 is January, 4 is April, 5 is May, 2 is February. Okay, and we're going to want to print March in D. So what are you guys thinking about this one? I mean, we see March right here. Let's do another vote for this one. So we think answer is A. Is there an error? No. It's going to print free. No. What about true? It's going to print true. Is it going to print false? That yes for true? Sandy?
Who's to say?
Who's to say? Was that a yes for true? Yes for true? Okay, what about false? Yes for false? Got a false down here? Bunch of falses over there. All right, well, it looks like we had no votes for A and B. So why don't we just eliminate those for now? Okay, so the question is it going to print true or false? Now, let's actually remember what this in command is going to do. So remember, when we look through dictionaries, are we looking by their keys or are their values? Their keys, yes, Lucas, thank you. We're going to be looking through the keys. So we're only going to be looking through these highlighted portions here. 1, 4, 5, 2, 3. So, is the string March in 1, 4, 5, 2, or 3? No. So this one's actually going to be false. So just remember, whenever you're using dictionaries, they're always going to be, or almost always going to be, with relation to the key. Any questions about that one? All right, Question 7 says the code in the cell is supposed to count the frequency of in each digit, 0 to 9, in the string called pi. Which command should be inserted in line 4 to obtain the output that's shown below in the cell? All right, so how are we going to do that? Well, first, let's take a look at this output and where this output comes from. So where does this output come from? It looks a little bit confusing here. How are we even getting that? Because we have, here in pi, we've got 1, 4, 1, 5, 9, 2. A little bit stumped here. What do you guys think? I'm not sure. I'm not sure at all. Any thoughts? Why don't we do another roll for this one? I think A. I can see a couple votes over here. Vote down. Any more votes for A? No. B. Any votes for C? What D? No. All right. I'd like to ask one of the A voters. Why don't we vote for A? Hey, you want to give it a chance?
I'm gonna be honest, just because it looks like the answer.
Because it looks like the answer? Okay. Well, you know what? If we're not sure, it seemed like this one we're a little bit less sure. Why don't we try and was that a hand over there? No. Why don't we try and rule out some of the answers we think it's not? Okay. So why don't we start with D? It looks like we have the least votes for D. So why not D? Well, character plus equals 1 here. Do we even have a CH defined? Like, we have a CH defined right here. But if we're adding 1 to a for loop iterator variable, so actually, just remember, we actually never want to change the iterator variable. So if we have a variable here in our for loop, we don't want to try and change it by 1. But even if we could, then that would just change how many times the for loop runs. It wouldn't actually do anything. So let's get rid of D. Okay, what about C? So what's C? We're saying L at our character. Now, L at our character. Actually, L is not even a function. Can we take L at CH? With those parentheses there, the curly parentheses? No. Okay, so what about B? Let's take the integer. Well, CH is already an integer. So since H is already an integer, the same as part D, we're taking CH plus equals 1. Can we do that? Then we'd be changing the iterator variable again. Can't do that. So that leaves us with one answer. A. Had a lot of A voters over here, so good job. Everyone happy with that one? All right, how about we move on to 8? So 8 says, look at the code in this cell. Ask which command should be inserted in line 5 to obtain the output that's shown below the cell. Okay, same as part 7. So what we're going to do here, I'll give you a couple seconds to look at it. We can vote on it one more time. It was always tough, It's always tough to, when you're not writing your own code, trying to understand other people's code. This is why comments are important. Good variable naming is important as well. All right, let's do another vote here. What do we think? A? Or do you want some more time? More time? Got some thoughts over here? Any ideas? You have an idea over here?
I think it's C.
I think it's C. Why do you think it's C?
Because in the output, like our key is the calories per 100 grams. So I know that needs to go first.
Okay.
Yeah, first I guess.
Huh. Okay, so Lucas thinks it's C. Do we agree with them? Yes? Oh, yes, for sure. Yeah, it's C. Any of the other vote yesers want to elaborate as to why they think it is? Okay, who thinks it's not C? Okay, you're all right. It is C. Okay. Good stuff. I think Lucas did a great job of explaining right there. Yes, our calories per 100 grams, this is at I, that's going to be our key. And we want to make sure we're taking our cow food dictionary at our key. Does that make sense to everyone, or do you want me to explain it a bit more? Everyone happy about that one? All right, let's move on. Okay, so question 9. All right, we're going to try and have to write our own code ourselves now. Okay, so it's going to give us two lists, L1 and L2 of the same length, containing real numbers or integers. And without using the max and min commands, we got to write the code to create the lists Lmax and Lmin. So Lmax is going to be the larger of each two numbers at each element. Lmin is going to be the smaller of each list at each element. Okay, how are we going to try and do that? Okay, well, like always, why don't we try and initialize our variables? So we're going to say Lmax is a list, and Lmin is a list. Now, why don't we do it like this, okay? I'm going to write some code, and just like in some of those questions, I want you to try and find the errors in my code. Don't raise your hand, just yell them out as I'm writing. Okay, so here's what we're going to do. Now we want to try and find the elements at each list. So let's iterate through the lists, and we're going to assume the lengths are the same. So we're going to iterate through for each index in the range L1. Now it doesn't matter that it's because both lists are the same length. So we can just loop through L1. See an error already? Where? Okay, so now what we're going to do is, why don't we check this? Why don't we, Anthony? You found something? Oh, go for it. What mistake did I make?
Should we find range length?
Sorry?
Range length?
Yes, it should be the length of L1. So keep in mind, right now what we're doing is we're saying in range of a list. But the range function works on an integer, so we need to take the len of L1. So these are all small things. Make sure we wanna keep those half points, We wanna keep all those half points. So we're gonna loop through the len of L1, or the range of L1. Okay, and then what we're gonna do is why don't we compare the elements at each index here. So if L1 is greater or equal to L2 at I, what's the A for? What's the A? Say that louder.
That's like not code.
That's not code. What did I mistake here?
The equal to should be next to it.
This equal to should be next to it. So there's no greater or equal to sign like that. So make sure we're going to be writing greater than or equal to like that. Okay. So after this if condition here, what we're going to do is why don't we take our Lmax list and we're going to append to our Lmax list L1 at our current index. So because we're saying L1 at our current index is bigger, we're going to add L1 at our current index. And if it's not, and we're also going to want to add to our min, we're going to want to add the smaller one. So since L1 is bigger, L2 is going to be smaller. And the reason why we're using greater or equal to is because if it's equal to, it doesn't matter which list they're going into, right? The same number, they can go into either list. Okay, and we're going to take an else. So if L1 is not bigger than L2, that means L2 is bigger. So since L2 is bigger, L2 should be the one to go in the max list. So we're going to take L2 at I, and then our L min is going to get our L1. Awesome. All right, and if you wanted, you could print the two lists, but I think for this question, we're done. Does anyone have any questions about that one? Everyone happy with that one? All right, let's move on. Can I zoom out, by the way? I realize there's not much showing on the screen. Can you still read that? Is that better? Yeah. Okay. Question 10. Given two dictionaries, D1 and D2, we want to create a new dictionary according to the following rule. Huh. This question looks familiar. By the way, this question looks familiar to something else. So you might have seen that other question. I'm not going to say where it's from, but if you have, then you can use the notes that we've seen here. Okay, awesome. So why don't we do this? It wants us to create a function, or actually it doesn't say it wants us to create a function. Sorry. Why don't we do this? Let's initialize our third dictionary, as always. Let's initialize first. Pardon my curly braces, by the way. I realize that I'm not much of an artist, but get the picture. All right, so now what we're going to do is, why don't we loop through. Now, have you ever seen, we're able to loop through the key and the values at the same time if we do D1 dot items. Add items. So dot items is a method that we can call on a dictionary to grab the key and the value. So now each key and each V are going to be for. Oh, that hand up, Sammy.
Why is there an empty bracket beside the key?
Oh, that's just because it's just to do with the method that we're calling here. So we're calling the dot items method, so we just need those empty brackets. It's the same as if you were to call a function that was empty, that didn't need any arguments. All it is that the dot items method doesn't require any arguments. Okay, so what we want to do is, if there's an element in D1 and an entry in D2, we want to add it to D3. So let's actually add a little bit of a drawing of what we're doing here. So if I may, we're going to have a dictionary 1, dictionary 2, and dictionary 3. So if our key and our value are present in D1, in D2, if we have a value, we have some other W here, we want our key in D1 to map to D2 in D3. So we're going to have K and W here. So notice we've got K, V, and W, and if we have some K where the V's are the same in D1 and D2, we're now going to map K to W in D3. Does that make sense to everyone? Concept? So what we're going to do is, if V is in D2, so remember, when we say the if something is in command, we're saying if it's in the keys. So the first thing we've done is we've looped through the key and value of D1, and now we're saying if V is a key of D2. Then what we're going to do is we're going to add to dictionary 3 our key K, which is from D1, and we're going to assign that with our value of D2, which is going to give us our W. Now this is slightly different from the assignment problem here. If it's not in it, we just have to add the words no match in a string. Then once this for loop is complete, we're done. Does that make sense to everyone? If you, I don't know, if you want to take some extra time to write this solution down for, I don't know why, but if you needed this one, just make sure to get that down before we move on. So I'll give you a couple extra seconds for that one, yeah?
Wait, Kyle, is that a K? What? Kyle, what did you write under D3?
Under D3? Oh, here, sorry, this?
Yeah.
That's K.
Sorry.
No, you're good. My handwriting is not the greatest, so let me know if you need clarification on anything. Just checking, want to make sure everyone's had the chance to copy this one down. Okay, so we've actually gotten to the end of both tests, which is a lot quicker than I thought we would. So we can try and do some practice problems if you'd like. Or if you'd like to leave now, feel free.